Hello and welcome back to the Go-Stroid development series. Today we'll be looking at projectiles and how we can create a manager that will handle all of our projectile needs for anything that actually needs them. Now, projectiles are usually pretty simple to make, and we'll design a system that we'll be expanding upon in our next video that will make our lives even easier. But for now, we're going to kind of just go over the basics of how we can create them and how we can, start using them to just be on screen and be floating around like we want them to. So to do that, the first thing I guess we should actually do is define what our projectile is, right? We need to give our game the definition of a projectile. What does it do? What is it going to be? What does it require? What variables does it need? So to do that, we're going to go and create a new scene of other node, and it's going to be of type character body 2D. I'm going to be using character bodies because velocity in this is going to be quite useful. So we'll stick with character body 2D. It is going to need a collision shape, as all character body 2Ds need. The collision shape in this, funny enough, doesn't actually matter because we won't be using it to collide with anything. So what we're going to do here is we're going to add the collision shape, then we're going to hide it, click on the character body 2D, go down to collision, and for now we're going to disable the layer and the mask. This basically means that the projectile will now go through everything. It won't attach to anything, it won't hit anything, it will just exist on screen as kind of a moving sprite. Now, you're probably going to ask, well, why aren't you using a sprite? As said, velocity, very useful when designing things like this. So let's go and rename the character body 2D. We're going to rename this to the base projectile entity. Now, my wording here is very specific. Base projectile entity. It's an entity, okay? But it's the basis of all projectiles that we plan on creating. So that's kind of what we're going to be using this as, and we'll be using some inheritance in the future to make different projectiles or different types of projectiles, like the UFO projectiles, or maybe some missiles or something along those lines. So with the base projectile entity named, let's go and add a sprite to this because we're going to need a sprite. And we're going to need one more thing, and that is going to be called a visibility on-screen notifier. Now, this is a very, very specific node. Now, I'm using Control A or Command A to pull up this menu. We're going to go and type vis or visible, and we'll get this. This visibility or visible on-screen notifier is a rectangular region of 2D space that detects whether it is visible on screen. That's really useful. Now, we are doing a thing with screen wrap, right? I don't want to have screen wrap attached to the projectiles. We can, if you really want to do that, because what that will do is add a new level of difficulty if you make it so the projectiles can also hit the player. But for this, we're not going to yet. We might change that in the future. What this is going to do, however, is say, okay, this projectile has gone off screen. I'm going to send a signal or fire a signal saying that it's gone off screen. We need that for a few reasons, and we'll get into those as we get into them. For now, let's go and add a sprite to our base projectile entity. So we have our sprite 2D. Let's go to the texture where it says empty. We're going to hit load. We're going to go into our assets. Let's go PNG, lasers. And now we get to pick out of all of these lasers. I'm going to use the laser blue 04 for now. That is about the size that I would like it to be. I can change this in the future if I need to. And this sprite will kind of be like how we have our meteors made, where we can, customize or change the sprite on the fly. But for now, we're only just going to use this base blue one because we only need to see the blue laser. So I'm going to rotate it so it's in the correct facing direction, which is along the x-axis. So along this line here, it needs to be facing in that direction. I'm going to hit Control S and save. We're going to go into scenes. We're going to create a new folder. It's going to be for the projectiles. I cannot spell projectiles at the moment. There we go. Hit OK and hit save. So we have the very basis of our projectile entity made. Now what do we want to do? Well, first, let's grab the visible on-screen notifier here. And then what we're going to do is grab the little move tool or move mode. We can press W for this if we want to. Then we're going to hold down Control or Command and left click. We're going to pull it along the x-axis just until the back of the little rect here, this little rectangle, is off the screen or off the back of the bullet or the projectile. That will basically make it so when the projectile is fully off the screen, it can just do something. Now, with that done, let's go into the base projectile entity. let's go and add a script to it. Now, I've got a lot of code here that I'm just going to kind of cut out. There we go. Now we are left with a completely empty script. So the first thing I really want to do is give it a class name. I love giving things class names, if you haven't noticed already, and it really kind of just helps when it comes to creating things. So this will be class name of base projectile entity. Now we're going to need 2 onReady variables. If you can guess what those are, go and add them into this now. If not, we're going to grab our sprite and our visible on-screen notifier 2D. So actually, we don't even need the visible on-screen notifier 2D. We can do something different with that. So we're going to just grab the sprite. To do this, we're going to left-click, drag, hold down Control or Command, and drop. And we get the onReady variable created. We'll typecast this as a sprite 2D for that IntelliSense or autocorrect. And now we need 2 normal variables. We're going to need one for the movement speed, because we want our projectile to be able to move, right? So we need movement speed. We're going to set this equal to a float of 0.0. And we're going to need a direction. So the direction we want to move the projectile in. So go var direction. This will be of type vector2, and we'll set that equal to the vector2 dot 0. Now, these are just presetting and predefining variables that we're going to be changing. So, if it's a vector 2.0, it won't actually move anywhere. It will just kind of stay in place. And if it's a speed of 0, it will also just stay in place. So we're going to need access to the process function because we're going to want to do something every single frame to do with movement. We'll just write pass in there for now. And now we're going to actually write the handle movement code block that we usually do. So what we're going to do is we're going to write func handle underscore movement. It's going to need the delta as a parameter, which is a delta of type float, and a void return type. Now, we've handled movement in quite a few different ways. Well, no, we've done one specific way, which is using move and slide. This one time, we are not going to use move and slide. We are going to use the other version of this, move and collide. So let's go and write move and collide. And you'll see that the difference between move and slide, at face value, the difference is that move and collide takes 3 different, or it expects at least one parameter to be passed through. So let's go and pass in that parameter, right? So the parameter that it's going to need to take is the direction it's moving towards. So where it's actually moving to, right? So in this instance, we're going to want to add the direction. So that's where we want it to go to. We're going to want to use times the movement speed. So we know exactly where it wants to go. And then times delta to make sure that it is frame independent movement. So this one line here will handle all of the movement for it to go from point A to point B. We will define where point A and point B is when we actually come to spawning the projectile, but for now, this is kind of what this does. Now, once again, a really cool thing you can do in Godot is if you hold down Control or Command and you click on this like move and collide here or any system or engine specific thing, it will take you to the documentation. So kinematic collision, move and collide moves the body along a vector motion. So that's what we've just defined with the little math that we did there. In order to be frame rate independent in node physics process or node process, motion should be computed using delta, which is what we're doing, and it returns a kinematic collision 2D. So this is a really long word. This is what it means, which contains information about the collision when stopped or when touching another body along the motion. That's really, 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 really useful, especially when we want to check what it's colliding with. So with that now you kind of understand what that is. You kind of now know why we are using move and collide. So let's hit Control S and save, or Command S and save. That is the movement function. But we now need a way of setting the direction and movement speed variables. And where this is a base projectile entity, the projectile entity, its whole job is just going to be to move from point A to point B. It's going to be moving a data container from one point to another in physical space, right? That's kind of what it's in technical terms going to be, which means we're going to need a bunch of setter functions. A setter function is just a function that another script can use to set parameters inside of this class, right, or inside of this projectile. So the first one we're going to create is going to be set underscore speed. It's going to take in parameters for new underscore speed of type float, and it will be of void return type. Right, for now I'm going to write pass. So I can explain this a little bit because we haven't actually used parametered or, any functions like custom functions with parameters in them before. So all we're doing is going, okay, when we call this function in another script, it needs to pass something in to be used correctly. The same way move and collide does. This is a parametered function, right? It needs to have a function or a parameter passed into the function for it to work. If we don't have that, and we just do this, it's going to throw an error saying it's expecting at least one parameter or argument, but has received 0. So let's hit Control Z and undo that. So we now know that's what we're doing here. So what speed are we going to set? Well, we want to set our movement speed equal to the new speed that gets passed in. That's going to allow us to set multiple different speeds from multiple different places and have just different projectiles at different speeds. That can be really useful. So what's the next one we want to do? Well, of course, we're going to want to have set underscore direction. So we're going to need to know where we're firing it, right? So we'll go set direction, we'll go new underscore direction of type float and of return type void. And now we're going to set our direction equal to the new direction. So that's great. We now have our speed and direction being set through parametered functions or functions with arguments. The final one I want to do is going to be the function for setting underscore the texture. Let me make some room here so it's a bit easier to see. There we go. Set texture. Now this is going to be a bit different to, taking a float, and this should be a vector2. So set direction needs to be a vector2, not a float. So it's going to be a bit different than a float and a vector2. This one is going to be a new underscore texture of type texture 2D. Now, if you remember to the previous video where we modified the textures on the asteroids when we randomized them through an array, we are modifying it with a texture 2D. And this is the same thing. So void return type, and we just want to go the sprite 2D dot texture is equal to the new texture. We now have our 3 setter functions and the movement handled, right? This is now just waiting for something to be passed, like actually use these things. So first thing we want to do is make sure that our movement gets called in the process function. So handle underscore movement, and we pass through delta like so. And now we get to do something that's not actually in the script, or it's not an already variable. We get to go and click on the visible on-screen notifier 2D here. Go to node, signals, and then you see the screen exited and screen entered signal here. We want to connect the screen exited signal. So we can double click on that, click connect, delete some of this white space, so it's a bit cleaner. And now inside of this function, we are going to just write the word Q3, or we're going to call the function Q3. All Q3 does is deletes the object from existing. So it basically just removes it, completely gone. So what this is going to do from a signal, as I explained, is the second this fires its I'm off the screen signal, or hey, I've left the screen, it's now going to Q3 the entire projectile. So it basically stops you from having 100,000 projectiles existing all at one time, which will eventually start to really slow down the program. You don't want that. So with that done, this is our entire projectile, or base projectile, created. Let's hit Control S or Command S and save. And now we get to actually move into a bit more of the fun part, which is the player ship stuff. So we're going to create a new scene. We're going to create a new scene of type 2D node, or node 2D like so. And we're going to call this the player weapon handler. So this is going to be a handler. It's going to contain certain things for every single weapon that we want to make. I'm going to hit 2D scene, I'm going to hit Control S and save. We have a folder separated for this handler's function. So I'm going to hit save inside of that. And now I'm going to add two things to, I'm going to add two things to it. I'm going to hit Control A or Command A. we're going to add a marker 2D. We're going to rename that marker 2D to primary weapon anchor, like so. And then we're going to add a script to the player weapon handler. So we're going to click on script, hit create, and now we have a handler or a new handler that will handle just the weapons for the player. So in this, we're not going to need access to the ready function, but we will need the process function. We're going to need to give this a class name again. So class underscore name player weapon handler. That way we can call it in other scripts if we need to. And now we're going to be needing two things. We're going to be needing a onReady variable for the primary weapon anchor. If you remember how to do that, I urge you to just do that now. Now I'm going to do it again. I'll explain how to do it. Drag, hold down Control or Command, and drop, and then typecast it as a marker 2D because that is what it is. It's a marker 2D. Now, why are we naming it a primary weapon anchor, and two, why is it a marker 2D? So I call this an anchor. It's not really an anchor. It's more of just a position, right? Now, we could attach a sprite to this anchor and use it as an actual anchor or as a position. We're not going to do that. We just want to use it as the marker 2D, which is just a positional container. So it's going to handle the data that contains the position or give us a point to fire from. So with that done, we now need to grab a exported variable. We could do this through an onReady variable and just have this immediately loaded if we really want to. Or we can just do an exported variable for this, which will make this a little bit easier. And this is going to be for the packed scene that contains our projectile. So we'll go projectile underscore packed underscore scene of type packed scene. And we set that equal to null. Then we hit Control S or Command S and save, hit the player weapon handler, go to inspector, and now we have a exported variable here that we can add or do things to. So this is what we're going to do. We're going to click the drop down arrow, hit load, go to scenes, go to projectiles, and grab the base projectile entity. So the best part about having a quote unquote base projectile entity means we can modify it in any ways, and we only ever need to have an exported variable for it once, and we can use it and turn it into a few different types of projectiles. We could turn it into missiles, we could turn it into lasers, pretty much anything really that is projectile related, which is really cool. But also having an export variable like this means if we move the location for the actual projectile scene around, it will stay exported correctly and it won't break anything basically. So what do we now need? We actually need one specific function, and that is going to be for firing the primary weapon. So we'll write func fire underscore primary underscore weapon. It won't take any parameters and will be of type void or of return type void. And we need to do one if check. We need to go if input dot is action just pressed fire, cap it off, and then go into the statement and hit pass or write path. So we're going to go to project settings, input map, and make sure that we have a fire input defined here with actual buttons used to it. So for me, fire is defined and used by using left mouse button, the E button, or space button. So make sure that these are a thing for you, or at least one of these buttons is marked to the word fire. To do this, you add a new action. You basically type in the name. We'll go fire2, hit add, hit the plus sign. I'm going to use right click for now for right mouse button. Click OK. And there you go. You've got your new fire defined. I'm going to delete that previous one because we don't need it. But we now have fire defined. So with fire defined, so we now know this basically says, okay, we're pressing the fire button. Okay, what do we want it to do? Well, we're going to want it to get a position for what we're firing at, and then create the projectile, spawn the projectile, set all of its variables, and then let the projectile do its thing. Right? That's the general idea. So to get its position, we're going to create a new variable, and this is going to be for the mouse underscore position. We're going to set that equal to get underscore global mouse position. If you want to be even more specific with this, you can do a typecast here, or typeset for this, and you can set this as a vector2, like so. If you want to actually, and this is a thing that I haven't mentioned, but if you want to skip doing this, you can actually just remove that part and use a colon equals, and it will grab the type of the variable and set this as the variable type. So you can use colon equals like so. So this now knows this is a vector2. I personally don't like doing that because this is just a little bit more readable to me. So we have our mouse position, which is a vector2. We're now going to want to grab the container that we plan on spawning this in. So I'm going to do this inside of the entity containers because it's an entity. So entity underscore container. This will be of type node 2D. I'm going to shrink this a little bit so we have a little bit more room to see. I'm going to set that equal to. Now, once again, we did this in the entity spawning video where I showed you how to spawn meteors and things like that, and then actually put them inside of a container. If you remember how to do that, go ahead. If not, the way that you do that is to go get underscore tree dot get first node in group, and then you pass in the string name for your container. So mine is the entity underscore container. Typing it by hand like this can be a little bit dangerous because typos can happen. So what you can do is go to the main scene, entity container, over to node, groups, and then you can copy the group here. And then you can just paste it in. There we go. So with that one done, we now need to do our if return check, right? Which is just checking if the entity container exists. So we'll go if entity container is equal to null, return. That's basically going, okay, the entity container for some reason, which shouldn't happen, doesn't exist, do nothing, stop this code block here, just do nothing more than that. That will, on the very rare occasion, save you from some really random and weird things happening that shouldn't happen but can. So this is just a, it's a null check. It's a, just make sure this doesn't happen check. So with all of the setting out of the way, we now need to create our new projectile. So to do this, we need to create one more new variable. It's going to be called the new underscore projectile. It's going to be of type base projectile entity. Now, this is how I would usually do this, where I go, of type base projectile entity. We're going to do this a little bit differently this time. We're going to go equals projectile packed scene dot instantiate. Now, if we use the typecast or typeset here by setting this as a base projectile entity like so, we may not actually get IntelliSense on this, which can be really, really annoying sometimes, especially when you're setting like projectile variables or things like that. So what we can do is actually just use a typecast using as base projectile entity like so. Now we will guaranteed get our IntelliSense on the new projectile, which is really nice. So now what we have to do is go new projectile dot set direction, speed, and texture, right? So what direction do we want? Well, we're going to want the mouse position minus the global position. And then we're going to want to wrap that inside of parentheses because this is going to be a little bit of an interesting thing here, right? So this is basically doing some vector math. This is going, I want to subtract the my position from the mouse position and get the point, like the actual point that we need to go to. Now we're going to do dot normalized here. Now normalizing this will basically return a value from 0 to 1 if memory serves. I need to go and check this myself. Normalize returns the result of scaling the vector to unit length, equivalent to vector divided by vector.length. See also is normalized. Basically, this a very interesting thing happens if you don't normalize this, where if you click far away from your player, you will fire a projectile at supersonic speed, and if you click it close to your player, it will go really, really slow. So normalizing it stops that from happening. Basically, saving you a small nightmare. So the next thing we want to do is grab the new projectile dot set speed. We don't have a speed defined in here, so for now I'm going to use I was going to use a magic number, and then my brain immediately said don't use magic numbers hurt. So we're going to go var, we'll go test, we'll do this in all caps, test underscore speed. It will be of type float. We'll set that equal to, let's go 1,000 for now. And then really, really little fun thing we can do is we can do a pound sign or a hashtag. We can go to do, and then we can write remove test speed, like so. And this is just something that, will really jump out to us and just be like, okay, remove this thing. So we now know when we read back through this to remove this thing. Creating little comments for you like this is really, really useful. So that's what we're going to handle in the next video. But for now, we have our set speed variable. So we can just pass through the test speed. The next thing we are going to want to do, right, is actually set the texture. Well, we don't actually have a texture we want to use yet, so we're not going to worry about setting the texture. We'll just leave the base texture that's in there. So what else does that leave us? Well, technically, right, with how we've done the meteors, the first thing you're probably going to go is, well, now all we really need to do is just spawn it, right, and set its position. Now, yes and no. The one thing that this isn't doing right now is rotating correctly. If I were to go and fire this projectile, actually, let's hit Control S. Let's finish off the script, and I'll show you what I mean by rotating correctly. So we'll go entity container dot add child. We're going to add the new projectile, and then just after we've added the projectile, we're going to go new projectile dot global position is equal to the primary weapon anchor dot global position. That way we're getting the position set correctly. We're going to hit Control S and save, and we'll hit play and see what happens. Well, probably nothing because I haven't added it to the player ship. Let's go and add it to the player ship real quick. So we're going to hit Control Shift A or Command Shift A, add the entity, not the entity, the base projectile entity. No. Control Shift A, there we go. Add the player weapon handler. Make sure that it's set up with the correct projectile. Hit Control S to save. And now we're going to click play. Now I'm going to left click and nothing is happening, and nothing is happening because we aren't doing fire primary weapon in the process. So let's go and do that. Fire primary weapon. Hit Control S or Command S and save. Hit play and left click. Now, yeah, as you can see, when we fire straight to the right or facing direction, the projectile looks fine. But when we fire up to the top, it's looks more like a wave than it does a laser now. So to fix that, we are going to go into where we are setting the speed and position here, just above the actual where we instantiate it or add it to the entity container. We are going to grab the new projectile dot rotation, and we're going to set that equal to the new projectile dot direction dot angle. Now you won't get IntelliSense for this little bit here, but this is a really, really cool thing where it will basically get the angle of the direction for us, and it will allow us to spin the projectile in the correct way. So let's hit play, and it's now firing in a straight line every single time. I can fire out as many as I can as fast as I can click. But we now have projectiles, right? We now have a little laser that's going at a somewhat decent speed that we can change and modify in the future. Now, as I said, they're not connecting with anything, so it's kind of just a little flashy thing we've got. But that is all I have for today. In the next video, we are going to be actually moving some of this code into a larger factory of sorts that's going to it's going to be a bit more complex. It's going to be a factory that will produce these things for us based off of a signal and a few resources. It's a really, really cool concept that once you really wrap your head around, will help you leagues in game development. But and yeah, after that, then we will handle like health and meteor, like the meteor destruction and things like that. And get to some really, really cool stuff. But thank you for watching. I hope you're having a great day, a great game dev journey, and I will see you in the next video.